Okay, the last lesson of the 0 chapter. And so this is 13. Guys, this one's graphing. Oh. You guys all can watch the video to hear you guys cry about it. Okay? Okay. Guys, so the first couple things we're going to talk about today is called a frequency table. A frequency table which can lead us to a bar graph, aka, I think possibly another one on there, it's going to be a histograph. Basically, to me, a histograph and a bar graph are pretty close to being the same thing. Now, guys, I'm still recording, so this is on the video, but I need you guys to be quiet today. Now, frequency table. A frequency table, guys, is this thing. This is a frequency table. It's just lists things with tally marks. So it lists things with tally marks. So the more marks you see, the more frequent it is, and then you can count up your frequencies to list them. So if I look at down there is, hey guys, who's having what for lunch today? And it looks like, and it really easily, the way it's organized, what's the preferred drink for lunch today? Coke. What's the least likely today? It's a Pepsi. Okay? So you can easily organize your data. Now notice that they're grouped into groups of what? What are they grouped into?
Brands.
What about those votes or those tallies? No. We got categories, but they're grouped into fives. Each one of these we can see is a 5, 5, 5. It's a very efficient way to tally up votes. So a bar graph, guys. What is a bar graph? Graph with bars on it. Yeah. It's just basically taking your frequency table, taking data that's already been grouped for us, and creating a table or a graph that can easily just be looked at to say this one looks like it's more than that one. And then sometimes, if it's done right, you can actually see the exact value, not all the time though, of what that bar is. So it uses bars to represent the data, right? I think I just wrote that wrong. Represent data. So uses bars to represent data. There's an S actually in this thing, in there somewhere. So let's take this frequency table of the drink of apple juice, Pepsi, Coke, or milk for lunch and create a bar graph. I've got a two-step process there. The first step says, draw and label your axes. Well, here we go. On the bottom, I am going to write my drink choice. Across the side, I will put number of votes, maybe, or, yeah, votes, because they're votes. So number of votes. What's the biggest vote count? Who's got the most vote? We said it was Coke. It happens to be 19. So I'm going to evenly space out 1, 2, 3, 4, and I will call that 5, 10, 15, and 20. Is that okay? You can see that the number of votes going on the side. And then across the bottom, guys, I am going to break it into the different categories. each tick mark there will be a category that I'll add a bar to. And the first one is AJ, apple juice. The next one is Pepsi, Coke, and milk. So what do I do from now? What's step 2? Just draw your boxes to the height that's appropriate. How much apple juice do people vote for? 15. So a bar should go up to 15. Boom. Next one, Pepsi. To get more smarter. So it's about 11. Coke. 19. And 17. The reason is, now these are not necessarily always perfect when we make them. Pretty much no graph is perfect when we make it, but it's kind of nice. I still can walk in here and say, hey, which one has the most votes? You look at it, oh, here's the tallest bar. It associates with Coke. The smallest is with Pepsi. And that's how we can read them. And you can say, okay, how much is milk? Well, milk is about here, so I go across. So somewhere between 17, 18. Happens to be 17. Yes? That's how we can use those. A cumulative frequency, guys, takes into account not just the category that you're talking about, but it also includes all the categories before it. So you're adding multiple categories. So if I'm talking about the second category, the second category would include in its frequency, the cumulative frequency, also from group A. So group C would include B and A. So maybe on the lines of people attending a wedding. So maybe the first group is kids. How many kids are attending the wedding? But the thing is that if I can break this backwards, I can say how many people in a family are attending, right? Well, the kids are part of that family. So if I have a family of 5 people in my family are going, 3 of them are kids. So the 3 kids are part of the family's column or bar. Histogram, guys, I'm not going to put a definition in there. Basically, histogram is a bar graph. A lot of times you'll start to see, though, is that your bars will be connected to each other instead of separated. Okay? Yep.
Isn't a histogram like a bar graph?
So there's the bar graphs. It's just using numeral data, so it's ranges. Yes, as Kathy says. But it isn't just a bar graph. Line graph, guys. A line graph is where you plot points. Plot points and connect. Sometimes. Sometimes you connect, sometimes you don't connect. It matters what kind of stuff we are talking about. And I see that the example is missing something. Okay, so I quickly created a little table here talking about the first 10 days of his job, and days 1 through 10 are on the left. The amount of hours he works is on the right, and we can see that that does change. So what we're going to do is just make a line graph to kind of show his first 10 days and how it's going to flow. So we go here and start to make a graph where, what's the maximum amount of hours he works? So we'll put hours going up the side, the day on the bottom. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I try to evenly space them out as possible. And now I have to use this same idea and show 12 going up the side. I don't know if I could do that. 1, 2, 3, 4, 5, 6. I only got 6, so maybe then I should do what?
Go by 2.
Go by 2s. Now, I'll tell you this. if I don't put a label on it, I'm assuming you're going by ones. If you put a label on it, then I will follow your label. So I do not have to personally write 1 through 10 across the bottom. If I would have just put a 1 there or just left it, I would have just assumed that is 1 through 10. So now all we're going to do is plot a point. At day 1, he goes how many hours? 7. Day 2, he works 5. Day 3, 9. Day 4, 3. 5, doesn't work any. 6 goes all the way to the top. 7, a little bit less. 8 is a 7. 9 is a 7. And back down to 4. There we go. Now, in this particular case, I don't think I'd connect them at all. So maybe up here, connect, put a maybe, or maybe not. Because in this case, I don't think it makes sense, but I could look at this graph and say, where's the day he worked the most? Way up here, which is associated with day 6. What day was the least? He must have finally had a day off after 5 days, yes? And you can kind of see his work schedule. Okay? Any questions to that? Okay, guys, the next one is a stem and leaf plot. A stem and leaf plot, guys, as I said there, has used to get large amount of data in order. Because I can basically ask you, what's the median of this group? That does not look fun to sit there and try to put everything in order, does it? So, these are the high temperatures the last 30 consecutive days. Actually, it looks about what the weather has been, in the last 30 days here, right? Some cooler days, some warmer days. So we got to make a stem and leaf plot. Now, a stem and leaf plot, guys, looks like this. So it's almost like the opposite of our other graphs, where it's a different corner. And so what we're going to do here is the leaves are here from the stem and leaf plot, and the stems are here. The stems, or we'll do the leaves first. The leaves, guys, are always just the ones position of a number. So, for example, 23. The 3 is the leaf. The 2 is the stem. The 2 actually stands for what, though? What's the 2 in that number? It's not just 2, it's 20. The 3 stands for 3. So that's why you get 23. I can go as far as what happens if this is 148. Here's my leaf. 14 is my stem. Okay? Now, I'm going to erase all of the writing. And what we're going to do is I'm going to create a cheating stem and leaf plot first. I am not going to properly make it. A proper stem and leaf plot, guys, not only just has the leaves in across the top on the row and in a column have the stems, but it has everything in order. So, what I tried to do is say, okay, what's the smallest number in the group? Look at our data. What's the smallest group? 60. You see a 64? I see a 64 as well. So 64 is here. Okay, I'm going to cross it out. Because 6 and a 4 makes 64. What's the largest number in the group? I see some 70s. I see 80s.
82.
No 90s. So, that means I need to cover 70 and 80s, right? There are no 90s. So at this point, now all I'm going to do is start in the top left corner, or in this case halfway through, and I'm just going to start to list all of my leaves in the appropriate spot. 72 is a 2. 74 is a 4. 72 again. 73. 75. 74. You guys see what I'm doing? Because the way to read this is 74. 73. Those are the numbers. We know which numbers are there. 70. Add a 0. Oops, I'm going in the wrong place. 82. 80. 82. 81. I'm going to pause the video and keep going. I ran out of room there. So normally you hopefully would never have that happen. But I now have all the number used. All of the numbers are used. I'm now going to go back. And I'm going to create it again. But this time, everything needs to be in order. Hey, happens to be the 60s are in order. So 4, 7, 8, 9. Now we have to go to the 7s and do the exact same thing. What's the smallest 7 number? Yeah. A 0. How many of them? I think there's only one. So there's only one of them. I'm going to cross it out. I'm going to switch to green so I can cross things out. The next lowest number? 2. How many of those? 1, 2, 3, 4, 5.
Just a quick reminder.
1, 2,
when the bell rings, we go into
3,
our class meetings.
4, and 5. I'm going to continue this without recording. We've now created an official stem and leaf plot. What you guys should start to recognize is that all of the numbers are in order. All of the numbers are in columns. So I want them nice and neatly placed in there. Obviously, this started getting a little wishy-washy over here because of how many numbers we had in a limited space. But here's the cool thing, guys. Using this, I can find the mode. I can find the median really easily. I've got 3 2s here, or 3 82s. I've got 3 80s. I've got 5 72s. Guess what the mode is? 72. Guys, I can also find the median by walking my way in. So when I walk my way in, I start at 9 and 2. I move into the next 2. I move to an 8. And then move to 7. In, and work my way down the list until you get to the middle. Awesome stuff. Homework is lesson 13, page P45, 1 through 5, and 7. Have a great day.